Hi my dear electrical aspirants, this is your Rashika sir from our SAIMEDHA coaching center. So welcome to all electrical aspirants who are preparing for KPTCL as well as AP and Telangana AEE aspirants. So generally the way of preparation should be very unique sir to get a job. After a long time there is a notification in AE, there will be a notification in AE. And in KPTCL also previously in 2022 I think, of course at that time few people missed by like a 0.5, 0.3 and 1 mark variation. And most of the students prepared for KPCL also recently, few of them selected of course and few of them justly missed. Now they have another opportunity, try to utilize this. And for Telangana students who are preparing, there will be a notification. We are waiting since last 1.5 years, still there is no any notification. Of course there will be a chances in next after the corporation elections like that. And who are preparing, for example, for electrical machine. If you come to electrical machine in this, what about EMF equation? On EMF equation, there will be a question in every examination. The question may be from transformer or induction machine or synchronous machine, but there will be a question from EMF equation. So how we have to remember the EMF equations and how we need to prepare and how we need to prepare a short notes. For example, if you take a heading of EMF equation, whatever the machine, the E average value is common. E average is equals to d phi by dt. E average is equals to d phi by dt. This is a common. For example, if it is a transformer, and this is my flux waveform, E average is nothing but, average EMF is nothing but change in flux by change in time. Let's take, this is a total time of t. Then can you tell me what is the time taken to reach from 0 to maximum? From 0 to maximum flux, how much time it will take? If totally t, then this is a t by 2, then this is a t by 4. So the time taken to reach from 0 to maximum is the t by 4. So what is E average now? Can you tell me? What is E average now? The change in flux. What is the change in flux from here to here? From 0 to maximum, which is increasing. That's why plus phi m is the change in flux. What is change in time? What is the time taken to reach from 0 to maximum? Is a t by 4. This 4 will come here. Then what is E average? The average EMF is equals to 4 into phi m into 1 by t. 1 by t can be written as frequency. This is what E average EMF in our transformer. That's it. That is what our EMF equation of transformer for average. If you want RMS, you know already. What about RMS? Generally, the RMS by average, which is called form factor. For a sinusoidal wave, its value 1.11. And maximum by RMS, which is called crest factor or peak factor, which is 1.414, which is a root 2. From that, if you have an average, you can find RMS. If you have a RMS, you can find maximum. We can find all the equations. This is a common equation, E average. This is for transformer. For example, DC machine. I want to calculate EMF. The same. For example, if it is a DC machine, E average per conductor is equals to d phi by dt. As usual, sir, there will be no change. What is d phi? For p poles, if I have a p number of poles, each pole 5 Webers. For p poles, p into 5 Webers. What is dt? dt is a time to complete one revolution. Time to complete one revolution. To complete one revolution. What is the time taken to complete one revolution for the rotor? In generally what we know, n revolutions per minute. Nothing but it can complete n revolutions in 1 minute. But I want to complete one revolution. For one revolution, how much time it will take? Can you tell me please? Cross multiplication, dt is equals to 60 by n seconds. 60 by n seconds. Now tell me, what is E average per conductor? E average per conductor is equals to, for P poles is a d phi, and dt, time to complete, 60 by n, where n will come here, P phi n by 60. This is what E average per every conductor. This is the E average per conductor in DC machine. So generally the generated EMF is different, 5Z by 60 something is there. Yes, this is E average per conductor. If you want total E average, send these conductors to here. P phi n by 60 into Z. This is for total number of conductors. For example, if I may have a 200 conductors in 4 parallel paths, 200 conductors in 4 parallel paths, each parallel path may contains 50 conductors. 50, 50, 50, 50, 50, 50 conductors, right? What is the total EMF? In each parallel path EMF, whatever it may be, that is the total EMF, because all parallel paths are there. In parallel, the voltage is same. For example, in each parallel path 100 volts, if each parallel path voltage 100, then the generated voltage also 100. It is not 400. So don't take total conductors in generated EMF. If you want generated EMF, the answer is 5pn by 60 into 200 by 4. Why 200 by 4? Those 200 conductors are settled in 4 parallel paths. So generated EMF nothing but, that is not a EMF of whole number of conductors. That is a EMF which produced in one parallel path. That's why divided by parallel path. This is the generated EMF of our DC machine. But the formula is same, sir. The way of derivation is different, of course. Let's go for synchronous machine. How we can calculate for synchronous machine EMF equation? In synchronous machine, also E average per conductor is equals to d phi by dt. As usual, there will be no change. D phi by dt. Already we calculated d phi by dt. What is the value? P phi n by 60. This is the equation for synchronous machine. Is it, sir? Yes, 100%. How, sir? Let's see. E average per conductor is equals to P phi by 60 into N. What is N? N is the speed. Already we know the speed of synchronous machine. What is the speed of synchronous machine? The speed of the synchronous machine is 120 F by P, which is called synchronous speed, 120 F by P. Let's calculate. PP gets cancelled. 60 ones, 60 twos. So what is E average per conductor? 2 pi F. E average per conductor 2 pi F. What I am discussing here? I have one conductor. In that conductor, the EMF induced generated is 2 pi F. Here another conductor, here also 2 pi F. This is totally called as one turn. Totally called as one turn. Now can you tell me what is EMF per turn? E average per turn. E average per turn for one conductor 2 pi F. For one turn contains always 2 conductors. One turn is equals to 4 pi F. E average is equals to 4 pi F. E average is equals to 4 pi F. That's it. If you want E average total Total E average is equals to 4, 5 F into T. What is E average for total number of tons? The total number of tons is equals to 4, 5 F into N. Here N will be the number of tons. Here T will be the number of tons. If you want RMS, multiply with 1.11, multiply with 1.11. If you want maximum, then again multiply with root 2. You will get all the equations. See how easy the way of preparation. In electrical machine, basic principle, all are comparable. Then after construction, all are comparable. Then after windings, mostly comparable. In that windings, EMF equation, mostly comparable. Like that, we need to compare all the machines during the preparation. That is way of preparation. Generally, the preparation gives you job, sir, not reading. Just not following. You need to make a new notes. You need to make your own notes. You need to compare all them. You need to make you should have some grip on the subject. You have to play with subject. Then you will get the job. That will improve your confidence. Just simply knowing is different, understanding is different. Simply reading is different, and understanding and referring and preparing, that will be different. That will give us job. Okay, sir? So this is the way how we have to make easy the subject. Right, sir? So who are preparing for KPTCL and AP Telangana AWE, for those aspirants, SAIMEDHA, which is established in 1994 by Dr.G.Ramana sir, ex-TRANSCO ADE, G.Ramana sir, ex-TRANSCO ADE, who will teach you maximum syllabus. So we started new live batch just today onwards. Today, 21st of January onwards, new live batch started. This is especially for working candidates who are working anywhere. For them, morning 6 to 8, evening 6 to 8, Monday to Saturday, and Sundays and holidays, at least 4 to 8 hours of classes. 4 to 8 hours of classes. Sir, if you are not a what we call a working student, then prefer for offline. We are providing offline coaching also in our SAIMEDHA coaching center. And today evening already you have a class by our another expert Nagaraju sir, and morning power electronics is going on. Who are interested, please try to join as soon as possible. Classes are going on. And for more details, our SAIMEDHA mobile number 9494941234 and 9494861234. Any number, if any number is in like a busy, then you can call to another number. Then you can call to another number, guys. Okay, be careful. And who are interested, please feel free to call these numbers. And tomorrow evening 5 p.m. to 6 p.m. we have a special demo for all aspirants by Chairman Ramana sir. As usually 6 to 8 live class will be going on, but evening 5 to 6 you have a special demo on preparation strategy. Who are going to join for our SAIMEDHA, how it will be. For a analytical view, sir will give you on tomorrow 5 p.m. to 6 p.m. on 22nd January, you have a demo for AWE. Right, sir? So for any details, you can feel free to contact these numbers. Thank you, guys.